Topic 3-4, factoring with greatest common factor. A lot of times you'll see your teacher ask you to write GCF. Find the greatest common factor. This can be referenced in our Holt textbook, Chapter 8, Section 1, starting on page 524, and also Chapter 8, Section 2, starting on page 531. Okay, when dealing with factoring, sometimes you're getting into the habit of just looking at factoring to binomials, but what you need to always look at is, can something be factored out with the greatest common factor first? So sometimes something can be put into maybe a binomial, but you can also look at factoring first a greatest common factor. So look at 15 and 9. There is something that is a factor of both of those, and that would be a 3. So I teach my students just to put it underneath. This helps in the division process. If you are going to factor out a 3, what stays inside the parentheses is the division of 15 divided by 3. So this would be a 5. We were not able to factor out an m because both terms didn't have an m, so that stays, and then negative 9 divided by 3 would be a negative 3. So stay in the habit of putting in the denominator, like make this a division, what can be factored out. This one, not just a 5 can be factored out, but also an x. You see an x in both terms. So to the outside of your parentheses becomes the greatest common factor. The division that takes place here is the 5's go away. You have 2 x's on top, 1 x in the denominator, and that becomes just an x. Both these x's cancel each other out, so the division of 10 divided by 5 is just 2. Okay, number 3, what can be factored from each of these is a 2. 2 goes into each of these. Anytime you see an even number, something that ends in an even, you always know 2 can be factored out. Sometimes it can be an even higher number, but if you end in an even number, always a 2. All right, there is an x in each term, so an x can also be factored out. So that is what stays on the outside, and what we place in the inside of this parentheses is the division. 4 divided by 2, 2. 5 minus 1 gives you the x to the 4. Negative 6 divided by 2 is negative 3. You subtract 3 x's and 1 x, and you're left with an x squared. 14 divided by 2 is 7, and the x's go away. They both cancel out. Alright, this one's got a lot of variables in it, but it's still looking at what can be factored out. Since this starts with a negative, let's factor out a negative. 4 goes into 8 and 12, and then look closely. What's the lowest power of a's? 1. So it would be factoring just 1a. The lowest power of b's happens to be over here. There's only 1, so that can be factored out. But look at our c. With c squared and c squared being in both of these, c squared will be what can factor completely out. That goes on the outside of the parentheses. What stays on the inside is the division of this to this. That becomes a positive 2. We're left with 1a, but the b and the c completely factor out in the first term. And in the second term, the a factors out. You're left with 1b, and the c factors out. So look carefully. If you could cross the same amount on top and bottom, here and here, the only thing that's left is the division of the b's. Okay, number 5. What can factor out here is a 3. You see an x in every term but not a y. There's only a y in the last two terms. So x, what's the smallest power of x? That would be an x squared. So this becomes x squared. After you divide, this would be x squared minus 3xy plus 2y squared. Again, notice that the x's would go completely away, but you're left with the y squared in the last term. Okay, let's look at one more problem. Actually, I don't want to get ahead of myself. Let's just look at this problem. A greatest common factor of 15 and 20 is a 5. And with all of the, you have an x and an x, a y and a y, and a z and a z. So you are going to have an x, y, and z, but let's get the powers that can be factored completely out. The smallest power of z is just 1. The smallest power of y is just 1. But the smallest power x is a squared. So 5 squared yz. It stays on the outside of your parentheses. Do the division, and you're left with 3xy plus 4z. 20 divided by 5 is 4. These x's go away, the y's go away, and then you subtract z to the 2, z to the 1 would be left with just 1z. Okay, this next problem is an application problem often tested on, where you're reading in words and then having to change it into an expression. The perimeter of a rectangle garden is 42 feet. The length of the garden is 6 feet more than twice the width. So let's write that in words. 6 feet more than twice the width. So 6 more than 2 of my w's. So your length now is written in this expression right here. So if we know what perimeter, 2 of my lengths plus 2 of my w's, remember perimeter is walking around it. You're walking around this whole figure here. Sometimes I'll have students put it either on the inside or the outside, but they're asking for perimeter here. So what we're going to use is substitution. We know that it takes 2 of my lengths plus the 2 of the w's to get my perimeter. So if you substitute in what you were given for your length in the expression, I'm just using substitution to put in what my length was, and therefore creating a single variable expression which can be combined, these two, to get 6w plus 12 is equal to 42. And you're going to subtract 12 on both sides to get 30, and then divide by 6 to get 5. Now be careful, because on your answer choices a lot of times this answer will be given in an A, B, C, D choices, but you've got to be careful because they didn't ask for the width, they wanted the length. So you're actually going to have to substitute this 5 into what your W was, because you've now discovered it was 5, and then add 6. So your length now is 16. You're finding the length of the garden is 16 feet. Okay, let's look at the next one. Altogether, Rob spent $52 for 2 shirts. So if we make X one shirt and Y the other shirt, adding those two together gave him $52, including the tax. The difference, and we know that the word difference means to subtract. The difference between the cost of the shirts is 18. So X minus Y is equal to 18. What is the cost of the most expensive shirt? Well, if you look closely in this system of equations, your y's would cancel out when we combine this. So let's just use our solving for x for this one. We have 2 x's, is equal to 70. So that X is going to be 35. Well, if one shirt is 35, you're subtracting to get the other shirt, so the most expensive shirt, if that's one thing we want to know, of the two shirts, the most expensive is going to be $35. And that concludes the Unit 3-4.